Hello everyone, I'm Ajay. Welcome to online Capgemini training. Today we're going to solve previous year DSA based MCQs, and the subtopic which we are going to discuss today is tree traversals. So let's understand what is exactly tree traversal. So all of you know what is tree data structure. It's basically a non-linear data structure which stores elements in a level by level fashion. If you take the example like 1, 2, 3, this is an example of a tree. So here this is called root and this is called left node and the right node. So that's about basic info about tree. So let's jump to the tree traversals. So as we know, every data structure has one or the other way of traversing the data, and even tree has different ways to traverse the data. So basically, it has three types of traversals majorly which are being used. The first one is pre-order. First one is called as pre-order, and the next one is in order, and the last one is post order. Pre-order, in order, and post order. Okay. In the pre-order, the logic for it is first the root node should be visited, then the left subtree, then the right. And in order, first the left, then the root, then the right subtree. And in the post order, first the left, then right, then root. If you take this example, the pre-order traversal for this tree will be root. Yeah. First root will be visited, then left, then right. And in order, left, right. Left, that is 2, root is 1, right is 3. And the post order, left, right, root. So first is left, then 3, then root is 1. These are traversals. And the basic trick to remember this root, left, right is, you know that pre means before or past. Before or past. And in means present. Post means afterwards, or you can say future. So based on that, first we can just try. You can just remember left, right. Here again left, right, left, right. So pre means before. Before means just keep the root before left and right. So root, left, right. In means present. Just keep the root in between left and right. Left, root, right. Post means afterwards. Just keep after left, right, root. So it pre means before, in means in the middle, post means afterwards. So root, left, root, right, and left, right, root. One more traversal is there, which is level order. Level order. If we take the example like 1, 2, 3, 4, 5, 6, 7, the level order will traverse level by level. 1, 2, 5, 3, 4, 6, 7. So level order traverse will be like 1, 2, 5, 3, 4, 6, 7. So that's about the basic info about tree traversals. Let's jump to the questions. Coming to the first question for today. For the given tree below, write the pre-order traversal. You know the pre means before. Before only we need to keep the root, left, right. So for the root 2, this complete thing is a left subtree and this complete thing is a right subtree. So first root is visited, so 2 will be visited first, and then left. In the left, this becomes root again, and this becomes the left subtree for this, and this becomes the right. So first root is visited, so 7 will be visited here, and here in the left again this 2 becomes root, this becomes left, this becomes right. So for this, first root is visited 2, in the left 6, and the right 5. So left is visited for the root 7, the right one, that is 11 will be visited. For the root 2, left subtree is completely visited, so right part. In the right part, this is null, left is null because nothing is there. So first right part, this becomes root, and in the root, first we need to visit this. So 5 will be visited, left is not there, right, in the right, this becomes root, here 9 will be visited, null, there is no left subtree, the right, 4 is there. So 2726511,594, which is option A. Option A is the correct answer for this. For the given tree below, write the post order traversal. It's the same tree, we just need to write the post order traversal for this. Okay, post means after left and right, we need to keep the root. Left, right, and root. So the complete left for this tree will be 6. 6 will be traversed first, then the left, then the right part, that is 5 will be traversed. Left, right, root. So 2 will be traversed. This complete thing is traversed. So this is left for this root. So root left part is done, right part 11 will be traversed. So left, right, and done. That is again left. The remaining is 7. That is a root 7. For the root 2, left part is done. So in the right part, just mention as null. So the right part first, left, right. So there is no left. So again left, right. Here 4 will come. Left, right is done. Then root 9 will come. Left, right is done. 5 will come. And we have traversed left part and right part. The remaining last is root will come. 652117495 652117495 option C is the correct answer for this question. What is the time constant for pre-order traversals in the iterative fashion? In the iterative fashion, pre-order traversal takes order of n. Do remember that in the iterative fashion, pre-order takes order of n as the time complexity. In the next question, we are given a pre-order traversal and in-order traversal. Okay, the level order sequence. So basically, like from using pre-order and in-order, we need to build a tree, and to the tree we need to do the level order traversal. Let's try the pre-order traversal. What's given here? A, B, E, C, D. Okay, and in the in-order, B, E, A, D, C. Fine. And you know that pre-order means root left, right. In-order means left root, right. Okay. So root left, right means A will be the primary root for the complete tree. So we can assume A is the root, and in the in-order, we can assume that left root right means root in the middle. So A is in the middle. This complete will be a left subtree for A, and this will be the right subtree for A. So this will be B comma C, and this will be D comma C. So now we need to choose whether B is a root or C is a root. Here again D or C. And here if you see root left, right, so B is visited first. B is visited first means B is the root. So we can assume that B is the root here and C will become child. But whether C is left side or right side of B, that we need to check from in order again. In order, you can observe that BE. So it means that the in order is left, root, right. Here the possibilities are B can be BE and null can be here, or B null or E can be here. The in-order traversal for this will be E B null, that is EB, only EB, and for the in-order traversal for this will be BE, and we know that B is given, which means that the left part is empty, the right part is the E, so we can keep the E here. So B and the right subtree will node will be E for this. Same way D comma C, first root is C for as per the pre-order. So C is a root, and here in the in order DC. DC means the only possibility will be like C, D, and here null. So then it will be left, root, right. So D will come here. So the tree is A, B, right side is E, A, C, left side is D. So for this we need to do the level order traversal. A, B, C, E, D. A, B, C, E, D. A, B, C, E, D. Option C is the correct answer for this. Let's jump to the next question. Consider following data and specify which one is pre-order traversal, in-order traversal, post-order traversal. Okay, so basically S1, S2, S3 are some kind of traversal given. We need to select such a way that these three are traversals, that's for sure, and which is which traversal, that we don't know. S1 can be pre-order, in-order, post-order, same way for others. So you need to find whether S1 is a pre-order and S2, or what exactly S2 is, what is exactly S3 is. So there are various kind of combinations given. And what everyone does is like they'll just solve all the possibilities, write S1, S2, and build the trees and everything. That might take a lot of time while solving the real examination. The only basic trick is that here, you know that pre-order traversal. In a pre-order traversal, the logic is root, left, right. And in the post-order traversal, the logic is left, right, root. Which means that the element or the data that came in the pre-order at the first should come in the post-order at last. That is the root. So let's check that sequence. Here if you check, n is there. Anywhere n is there? No. Again n is there. N is there? No. M is there. Anywhere m is there? Yes. So it means that if S3 becomes a pre-order, S2 should be a post-order. Let's see if any such combination exists. Yes, S3 is pre-order, S2 is post-order. We can blindly check. Option C is the correct answer. So let's jump to the next question. The post-order traversal binary tree is OPQRSP. Then possible pre-order traversal will be okay. Okay, pre, which is root left right, post, which is left right root. Okay, the post-order traversal binary tree. So there is a post order given and there is no other order given. We need to find which can be a possible way, a possible traversal for pre-order. We can say that the last element will be the complete root of the tree. So we can just keep t here and the t will be divided into left and right. So we can assume two combinations. One will be OPQ here and RS here. And another combination will be OP here and RS because equally both left R sorry QRS equally left and right will be divided. So this is one possibility. And the OPQ here we can see that OPQRS in the RS first S is there, which means S is the root, R is the child. So R comes here, and here OPQ OPQ here in the OPQ Q is the root. So Q becomes root here OP and the OP first OPQ. OPQ means left, right, and root. So this should be left, this should be right, and this should be root. So it means this should be left, O should be the left, P should be the right, Q should be the root, S and R. In the same way, here RST, S comes here, and QR are left child. So Q and R for the S, and OP, P becomes root, O becomes this child for this. That's done. So there are some combinations for this here now. So let's check which one satisfies. For this pre-order will be root left right. So T Q O P SR. Here it will be, so the combination will be T Q O P S R. Here it will be T P O S Q R. TPO SQR. TPO SQR not there. TQO PSR. Yes, TQO PSR. Option C is the one of the possibility. There are various possibilities also may exist, but this is one of the possibility that for the given post order, this can be a pre-order traversal. So let's come to the next question. Pre-order and in-order traversals of a binary tree are given. Which of the following is a post-order traversal? Okay. So based on the pre-order and in-order, we need to construct a tree, and to that tree we need to do the post-order. Okay, the given pre-order sequence is yeah, T M L N P O Q. Okay, and the in-order will be L M N T O P Q. You can observe, we know that pre-order means root, left, right. In-order means left, root, and right. Okay, so T will be the root here as per the pre-order. T will be the root here. Okay, So the elements before this, so here it will be root here, the middle element. This will be the left subtree, this will be the right subtree. So LMN will be the left and OPQ will be the right. So from the LMN, one will be the root, one will be the node, that is a parent node. So here in the next pre-order traversal, M is visited, which means this should be the root. So M is visited first. Yes. And here if you check, it's left right root LMN, which means it is to the left of N and N is to the right of N. We can say LMN is the left of T, and OPQ, MLN, both are listed P. So P becomes here, and here it's given as OPQ. So O will be the left side of P, Q will be the right side of P, because we know that in order, in order, left, right, and left, root, and right. So if P becomes root, then O will be the left of P, and Q will be the right of P. The tree which we generated is T, N, L, and P, O, Q. So we need to find the post order for this. Post order is left, right, and root. Left, right, root means first left side, that is L. L will be listed first, then next N, then M, and in the right part first O will be listed, then Q, then P, then finally T. L N M O Q P T. L N M O Q P T. Option A is the correct answer for this question. Okay, find the post order answer for the given binary tree. Okay, post order answer, post order, left, right, root. Left, right, root, first left is S. Okay, S visited, and the right part S, T, W. So W is visited, there is no right part, so T will be visited here. Left and right are done, Q will be visited, that's the root for this. And here left part is done, in the right part S, U left is not there, so this is null. And here X will be visited here, then U, left part is done, and the right part V will be visited. After that R will be visited, left and right both are done, P will be visited. SWT QX UVRT. SWT QX UVRT. So option C is the right answer for this. What is the specialty about in-order traversal of a binary search? Okay, now those of you who don't know about binary search tree, it's a special kind of tree in which if this is a root and this is a left node and this is a right node, as per the binary search tree, left is less than root and its right is greater than root. Means the elements less than root will be stored in the left side and elements greater than root will be stored to the right side. This is the concept of binary search tree. And the in-order traversal concept is, in-order means middle, that is left, root, right. So first left will be visited, then root will be visited, and right will. If you can observe, if you can take an example like 1, 2, 3, then it will be like 2, 1, 3. The element less than root will be stored left side, the greater than will be stored right side. This is done. So if you do the in-order traversal for this, it will be left, root, and right, which is 1, 2, 3. You can observe that every time the least element is selected, then the middle element, then the right element. So this way we can traverse. If we traverse a complete binary BST in order, it will give the output again in a ascending order. So that's so we can say option B, that is it traversing an increasing order. For the option for the question 9, option B is the correct answer. Okay, the last question for today. What does the following piece of code do? Okay, there's a function given root, and the root, okay, it's a recursion, root dot left, root dot right, root dot data. Okay, so let's take this only, 2, 3. Okay, so we have function in this root means one will be passed here, one address. In that, first is root dot left, then root dot left, root dot right, then root dot data. What is root dot left? Root dot left means 2 will be printed here. Sorry, 2 means 2 address will be passed to the function. In the function there is no root what you call any left or right for this 2, so only the data will be printed, that is 2 will be printed in the output. Again, this complete recursion is done, and the next part, root dot write. Root dot write means 3. So function of 3 will be passed. So 3 address will pass and 3 will be printed. 2 3 is printed. At last, root dot data, that is root 1, so 1 will be printed. You can observe that is 2 3 1. So basically, first left is being traversed, then right is being traversed, then the data is being printed. Left, right, and root. This is the logic for post order. So option C is the correct answer for 10th question. That's it for this video. All the best. Thank you.